Hello everyone, today we are going to talk about the liquid-liquid extraction.
If this reaction looks familiar, then that might be because it represents the basic form of a chemical reaction, in which you have a single product C or multiple products C, D, E, and so on, being formed from a combination of multiple reactants. Oftentimes, we desire just one of these products to form, and then this desired product must then be separated from the mixture of products or the mixture of products and reactants if the reactants are not completely used up, as is the case in most chemical reactions and processes. This area and field of separating chemical substances from one another is a major part of chemical engineering and chemical processes. Or you could use the separation technique we're discussing today if the two liquids have different solubilities in a third liquid. It's liquid-liquid extraction, or LLE.
What is liquid-liquid extraction? Liquid-liquid extraction is a method used to separate two immiscible solvents with different solubility. Typically, the solvents are in an aqueous phase and an organic phase. Liquid-liquid extraction is utilized across various industries such as pharmaceuticals, environmental science, and chemical analysis. Let's say we have a mixture of sodium chloride and cholesterol. These are both white and crystallized solids, which is impossible to be separated. But we can use their physical properties to separate them. Sodium chloride is an ionic compound, which is water soluble. Meanwhile, cholesterol is a steroid, which is a type of liquid and therefore non-polar and large water insoluble. But cholesterol can be easily dissolved in a non-polar solvent like ether. So, to separate this mixture, we can put in some water and some ether, and then we stir it up before putting it in a separatory funnel. Since the solvents are immiscible, which means they do not mix, we will get two layers in the separatory funnel. On the bottom layer, we will get an aqueous layer which contains all of the water and the natrium chloride that has been dissolved in the water. On the top layer, we will get an organic layer which contains all of the ether and all of the cholesterol that has been dissolved in the ether. Since the water is more dense than ether, it will be at the bottom layer. So, to separate these two layers, we'll just open the funnel and then we drain the aqueous layer into a flask just barely until we get to the organic layer. After that, we pour the organic layer out of the top of the separatory funnel into another flask. And then we evaporate the solvents until we get the substance nice and separated.
The key principle of the liquid-liquid extraction is related to the partition coefficient K. The K is a quantitative measure of the solute distribution between the two phases, and the formula is given on the slide below. The larger K value imply higher affinity for the organic phases, but then the K value will be affected by parameters like temperature and the pH. The K decreases as pH increases, and the K decreases exponentially as the temperature increases also. So in conclusion, the high pH and temperature reduce the solubility of the solid in the organic phase or favor the aqueous phases. So there are three factors that influencing the liquid-liquid extraction. The first one is the solvent selection. A good solvent has high selectivity and a favorable partition coefficient for the target solute. It should be immiscible with the other liquid phase, non-toxic, and also environmental friendly. Next one is the polarity. The solute solubility is influenced by the light dissolved light principle. Polar solute prefer aqueous phase, while non-polar solute favor organic solvent. And last one is the pH. pH adjusting the pH can change the ionization state of solute, altering the solubility in aqueous vs organic phase. For example, the weak acid and base can be protonated or deprotonated to shift their distribution.
Now I will explain about the application for LLE, which is liquid extraction. So they have three that we have do a research, which is first environmental remediation. So LLE is employed to remove a contaminant from wastewater and other industrial effluents. So this process is to separate the harmful organic or inorganic compounds like pesticides, heavy metals, and to ensure the safer discharge with environmental regulation. So next is food and beverage industry. In the food and beverage industry, liquid extractor is used for removal of undesirable compounds such as unwanted flavor, odor, and impurities. So this is help to improve the quality of the food for some products. And next, or lastly, for pharmaceutical industry. So LLE is play a important role in pharmaceutical industry, like purification of APIs, which is active pharmaceutical ingredients. It used to isolate and purify from reaction mixture, ensuring the removal of impurities or byproduct. And it also help to separate and concentrate specific compounds, improving drug formulation and stability. So next, they have a video that I have attached, which is a video for extracting caffeine from tea. So enjoy the video.
Liquid extraction has both advantages and limitations. On the plus side, it allows selective separation, efficiently isolating specific compounds based on their solubility. This makes it highly efficient, often requiring fewer steps compared to other methods. Its versatility is another key strength, as it can adapt to a wide range of applications by using different solvents. However, there are limitations. Solvent selection can be complex, often requiring trial and error. Additionally, the use of organic solvents raises environmental concerns due to potential toxicity and disposal issues. Finally, it is less effective for separating compounds with similar solubility properties, which reduces its efficiency in certain cases. In summary, while liquid extraction is a powerful tool, understanding its limitation is essential for optimizing its applications.